All right, guys, let's get into inverse functions, being able to find them and prove them. So let's start out with a pretty basic, little simple warm-up here. Table of values, right? We have f of x and g of x. F of x says the rule is x plus 4. And I give you a table of values, so let's see what happens. So if I have negative 2 for x, negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 0 plus 4, 1 plus 4, and 2 plus 4. Okay? Let's look on the other side here and take a look at g of x. So the rule for g of x is x minus 4, right? So let's see what happens. If x is 2, 2 minus 4 is negative 2. 3 minus 4 is negative 1. 4 minus 4, of course, is 0. 5 minus 4 is 1. And 6 minus 4 is 2. So I want you guys to take a quick look at those and see if there's anything going on, any sort of relationship with the rules and the functions themselves. Hopefully, when you're seeing x plus 4 and x minus 4, it kind of seems like there's some sort of relationship there. But take a look at the ordered pairs. Okay, if you notice, and I set this up this way on purpose, the y values here ended up becoming the x values here. And notice then that the x values are now the y values. So you could say like these ordered pairs just kind of switch spots, right? The x's and y's switch spots. And that would happen no matter what ordered pair we chose. I could choose any x value and find the y value, and then its opposite would be in the other table, okay? And that's because these guys are inverses, right? If you think just real simply, f of x, think about it. It's x plus 4, right? Take a number, add 4. Okay, if you take that answer and plug it in here and subtract the 4 right back off, it's just going to undo what the first one did. Okay, that's what inverses are. And this table was just a way to kind of see, graphically, these things are going to have their ordered pairs, their x's and y's are just reversed. So let's talk about how do we find the inverse of a function, right? Because that one I gave you two functions and we just kind of messed around with them. But what if I just give you a function and I say find its inverse? Okay, there's really just a few steps to doing that. It's pretty straightforward. Instead of g of x equals, it's going to be probably easier to think of it as y equals. So let's just replace the g of x or f of x or whatever they name it with y. And then the big thing that's going to happen with inverses is the x and the y are going to switch spots. So we're going to interchange x and y, and we're just going to rewrite the problem. Okay, and that's really the biggest thing. Whenever you think inverses, the first thing that needs to come to your mind is switch x and y. So if you're kind of stuck on what step to do next, switch x and y. Okay, now all we need to do is solve this new expression, this new equation, I should say, for y. Okay, so let's solve for y. Using some algebra, we can solve for y by adding 14 to both sides. Right, so x plus 14 will equal 4y. And then we're going to divide both sides by 4. Okay, so let's do that. So you can either write it as x plus 14, the entire quantity divided by 4. Okay, or another alternative would be if you wanted to divide them each by 4, it would be x over 4 plus 14 over 4, where you just kind of split up the fraction. So either way is totally fine. This is probably a little easier, right? But just be careful, if say you're taking a multiple choice test or something, make sure you know that this guy down here is equivalent, and you don't want to get that marked wrong. So that would be the inverse. One thing you might see too, there is kind of a symbol for inverse. Since the original function was g of x, the inverse, you just put a little -1 exponent there. Okay, it's not really an exponent, it's just a superscript, and it's just letting you know that it is the inverse. Let me just rewrite. I don't like how that looked. So it's just letting you know it's the inverse of g, and the answer we got was x plus 14 all over 4. That would be our answer. Okay, so that function undoes whatever g does. Okay, just like in the warm-up, x minus 4 undid whatever x plus 4 did. We just switched x and y, and then we solved for y. That's how you find an inverse. And you also... All right, so we just showed how to find an inverse. Now, to prove something is an inverse is actually a little bit different. To prove it's an inverse, you have to use composition of functions, which is one of the operations. Remember the f of g of x and then the g of f of x, all that stuff. This actually proves that two functions are inverses of each other, and there's really no doubt. Like if you get it, if you can prove this algebraically, you've proven it for all cases. So here's kind of the rule, and then we'll go through an example, but there's two things that need to happen. First off, and let me just write them out, then we'll talk about them, is that f of g of x must equal x, and g of f of x must also equal x. Okay, so it's basically, again, just composition of functions. Remember this f of g stuff here. Okay, that's the same thing. Both directions, though, have to both equal x. Okay, so let's show those ones from the warm-up. Let's do that. That's a simple example. And then once we show that, I want to just talk about what we really did. So from the warm-up, I know the two equations, the two functions were f of x equals x plus 4, and g of x was x minus 4. Okay, so if we can show, let's start out by doing, it doesn't matter what we do first. If we do f of g of x, okay, let's find that first. Okay, so refresher on that, f of g of x, you start with the inside function, so g of x is the one in the parentheses, so we're going to replace g of x with x minus 4, okay, because that's just what it's defined to be up here. And now we look at the rule for f and we say, okay, what is f of x? Right, so f of x given to us is just x plus 4. So in our case, we need to be doing f of x minus 4. So f of x minus 4, the x minus 4 is just going to go right here. So it's just going to be x minus 4, and then there's a plus 4 sitting out there right here. Right, and x minus 4 plus 4 is simply x. Okay, so this first condition is met. We've shown that f of g of x equals x. Let's now do the other direction, the other order, I should say, g of f of x. Okay, same thing. We're going to start by replacing the inside function. F of x over here is x plus 4. Okay, now we're just going to go look at the rule and see what do we need to do to do g of something, right? G of something is just that something, take away 4. So g of this is just this, and then minus 4. Okay, and x plus 4 minus 4 simplifies to just equal x. So we've shown both things are true, okay? Both directions with the composition both equal x. And all that's really saying, again, think about right up here, right? Okay, first off, when you do composition, you're first doing this, right? So I want you guys to imagine you pick a number and you do g to it. Okay, g is like a rule, right? It sounds weird, do g to it. But g is just saying over here, take your number and subtract 4. Okay, so everyone have a number in your head? Subtract 4 from it. Okay, got a new number? You take your new number, your answer, and you now apply f, which says basically just add the 4 right back. Okay, so you had your original number, you subtracted 4, now you added the 4 right back. You're going to get right back to whatever your original x value was. Okay, that's all this is saying. Okay, it seems complicated and weird and stuff, and it's kind of messy, but it's really just saying, you know, you do one function and then the other one undoes it and gets you right back to whatever x you originally started with. Need to be able to prove things are inverses using the composition in both directions. All right, so let's do another one. Let's prove that the inverse of g of x equals 4x minus 14 is g inverse of x equals x plus 14 over 4. Okay, so this is the one we did a few minutes ago too. But now we're actually proving it. We're not just finding the inverse. Okay, so to prove it again, you need to plug one into the other. So I'm going to find g of g inverse. Okay, this is like doing f of g of x. I just happen to name them g and g inverse. I want to show that this equals x, so let's do it. Okay, so again, first step is always to replace or substitute the inside function. So we're going to be doing g of x plus 14 over 4. Okay, so all I did so far was replace the inside function. Now I'm going to go take a look over at the rule. I'm doing g of something, right? G of something says 4 times that something minus 14. Okay, so g of something equals 4 times that something minus 14. See, I just used this format, or kind of like this shell, and I just plugged in the expression for where the x was. It's 4 times the x, and then minus 14. Okay, so when we do this, when we simplify, notice we're multiplying by 4 out here, but then we're dividing the 4 right away. So this is x plus 14, and then there happens to be a minus 14 sitting out there. Okay, and that simplifies to just x. Okay, so far we've got one of our two. Okay, we've shown the one direction of composition equals x. Now we do need to show both directions work. Okay, we're showing that these things are inverses of each other. So let's do g inverse on the outside and regular old g of x on the inside. Okay, let's again think about the process. So g of x is the inside function. G of x was just the 4x minus 14. Okay, so I replaced the inside function first, right? I just replaced that with that. And now let's do this rule to this expression. Okay, so the rule for g inverse is right here, x plus 14 over 4. So our x value is actually 4x minus 14. Then there's a plus 14, and it's all over 4. And we just need to algebraically keep simplifying this, and hopefully it ends up at just x. So let's see. So up top, 4x minus 14, and then plus 14 is really just 4x. There is a divided by 4 in the bottom, and the 4 divided by 4 reduces to just be 1, and we just have our x. Okay, so we have now proved, right? We proved it. We showed the composition in both directions simplifies to just equal x. Okay, and it needs to just equal x. Sometimes there's a question like, what if they both just equal the same thing? Is that okay? No, it's not. It needs to get you back to whatever your original x that you plugged in was, and it needs to do that for both directions. Absolutely. Okay, last thing I just want to show graphically with inverses. So all we did here, I just graphed the two functions that we just kind of dealt with. 4x minus 14, you'll see, is just a linear piece. It's the black graph there. And the x plus 14 over 4 is actually just a different linear piece as well. But all I wanted to show here was basically one little property that we talked about, how the x's and y's kind of switch spots. Let me just pick an ordered pair. This is on the x plus 14 over 4. That looks like it is the point 10, 6. So that means, right, that the xy is reversed, right? 6, 10 over here is going to be on the inverse function. And you can see that it is. Okay, so just kind of graphically, that's one of the things going on. One other thing graphically, just while I'm thinking about it, these lines are actually a reflection over the line y equals x. Okay, sorry, I meant to do that dotted the whole time, or dashed or whatever, but that would be like a line of symmetry, right? You can see these two lines, the f of x and g of x and its inverse. If you were to fold the paper on the green line is y equals x. These things would kind of line up with each other, okay? And that's kind of why the x and y can switch spots, because it's a reflection over y equals x, so they can switch. Okay, so that's a graphical representation. So make sure at the end of this you are able to find the inverse of a function. Okay, remember when we